cardinal number this is sometimes called cardinality of a set A is represented by n of A. I'll come back to that in a second. And what is cardinality? It is the number of distinct elements in set A. Okay, so this gives me the number of distinct elements in any set A. Remember that sets are defined as either having things inside them or not, either having elements or not. So when I'm looking at how many things are in a set, I need to be careful and say, well, if A is an element of a set, if lowercase a is an element of a set, then it's in there. Like, I don't count it more than once just because maybe someone wrote it more than once. This notation, n of A, is actually function notation. And I can put whatever I want in this set, or inside of these parentheses, to say I want the cardinality of that thing. So since this stands for cardinality, sometimes I'll say, instead of saying n of A, I'll say the cardinality of A. All right, let's look at some examples of sets, and I want to find the cardinal number of the sets or the cardinality. So I want to determine the cardinal number of the following set. A is the set 1, 2, 3, 4, 5. Well, using my very impressive counting skills, n of A is 5. The cardinality of set A is 5. There are 5 distinct elements in that set. Let's do another example. B is the set Z, 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 W, W, W. Now, whoever wrote this set out in roster method was confused. Like, they did not remember that sets either have elements in them or not. This set is the set that has Z and W in it. It doesn't have any other elements than that. So when I take n of B, or find n of B, I'm going to get 2. The cardinality of that set is 2 because there are only 2 distinct elements in it. And like I said, this would be a better way to write the roster method, or roster version of it, because I only need to list out the things that are in there. Listing them extra times doesn't do anything with a set. There's a mathematical object that cares how many times or some element appear in it, and that's called a bag. We're not going to do anything with bags, but thought I'd mention it. Okay, here's our favorite set, because it's a little confusing sometimes. I want to determine the cardinal number of this set, the empty set. So I want to know what is n of the empty set. What is the cardinality of the empty set? Well, when I ask myself how many distinct elements are in this set, I can answer that question. How many? 0. The empty set has no elements in it, so the cardinality of the empty set is 0. Okay, determine the cardinal number of the following set. So G, the set of all x such that x is a natural number, x is a member of the natural numbers, and 7 is less than or equal to x is less than 11. Well, let's write set G out here. So natural numbers starting at 7, 8, 9, 10, but I don't want 11 because 11 doesn't have an or equal to in front of it. So that looks like 1, 2, 3, 4 items. So the cardinality of G is 4. Okay, just one more. I've got the set of all x such that x is a letter in Mississippi. Well, what does this set look like? Letters in Mississippi, I've got M, I've got I, I've got S, I've got another S, but I already have that in there. And then I have an I, which I already have in there, an S, an I. Hey, I don't have a P in there yet, but then I have another P, I've already got P in there, and then an I. This set is just this one. The roster method has MISP, so the cardinality of this set is 4. I could say N of this set is 4, but this is another reason that we sometimes give sets names, because if I call this set set M, then N of M is 4, and I can have a little bit less writing, a little bit shorter notation.